So today I'm demonstrating a RF backscatter device. This is a basically one transistor based device which uses that transistor to modulate RF signals. Now those can either be ambient RF signals or directed RF signals. And in the demonstration I'm doing here today, I have a HackRF SDR, which is actually just monitoring a particular frequency that is set by the antenna that this device is using. Today that frequency is 2.48 gigahertz, which is sort of in the upwards top of the band of Wi-Fi. I think that's channel 13 in Wi-Fi terms, or inside of channel 13 when Wi-Fi is normally being used. And basically what this is doing is I have a signal generator which is generating a square wave at a frequency of my choice. I'm using 2 megahertz right now just because that seems to work well with the other software settings that I have. But anyways, that 2 megahertz signal is switching this transistor on and off. This transistor is a SKY65050 65050 is what it's called. It's a depletion mode PHEMT. You can get them from Mouser currently in January 2021. I think they're about $2 a pop, so they're not very expensive. And in this transistor, you have to do a little trick called self-biasing, which basically uses a resistor and a capacitor between the source and ground in order. Normally this wants to be biased at a negative voltage, but if you put this resistor between the source and ground, it makes the reference voltage, a positive voltage, look like a negative voltage, so everything works out fine. But anyways, the purpose of this video is to sort of give you an overview of the experimental setup here. What I'm trying to do is sort of recreate techniques demonstrated by Michael Osman, the creator of the HackRF, and hopefully get this out there so other people can recreate this, and also sort of showcase some of the struggles and questions that I have encountered while I was developing these things. So if you're watching this and anything that I say in this video sounds nonsensical and you know more than I do, which is very likely the case because I'm just getting started with this, please feel free to chime in and let me know, or send me an email because I would love to talk to you more. So here's a basic overview of the setup. This is kind of a mess of probes and alligator clips right now. And what you can't see under this oscilloscope probe, let's see if I can unhook it there, is the SKY65050 RF transistor. I can't get the camera to focus. The red clamp on the left, the alligator clip, is hooking on to a juncture which is applying the square wave signal to the source, and then this other wire on the right hand side here is the antenna. The clamp below that, the red clamp, is applying 3 volts. This capacitor up here is a 1 microfarad, I believe. Yeah, 1 microfarad, which is used for RF coupling, and then the resistor there is a 22 ohm resistor, which is used for that self-biasing that I was talking about earlier. Then on this side, I actually have 2 HackRFs set up. Their clocks are linked together, but right now I'm actually only using this far one, which is hooked up to this log periodic antenna. It's a broadband antenna that works from like 1 gigahertz to 9 gigahertz, and right now we have it tuned to 2.48, which is roughly what this antenna is set up for. Sorry again about the focus. But anyways, let me hook the oscilloscope back up and then walk through. Okay, so now the oscilloscope probe's hooked back up. Let's go ahead and launch GNU Radio over on my laptop. The application I'm using in GNU Radio is actually straight from Michael Osman's GitHub. This is from his NSA playset demonstration project. Okay, so we'll go ahead and launch this. All right, so what we have up here is a windowed average that shows 1s and 0s, and this is raw amplitude. Every once in a while you'll see some maybe see some signals pop up. That's probably just from ambient Wi-Fi traffic. Also, we have the oscilloscope here, the power supply, and the function generator. So I've got a 1 megahertz signal, square wave, 5 volts here. We go ahead and turn this output on. Then we'll see the voltage consumption change. Here's what the signal looks like going to the source, the gate, sorry, of the transistor. Or actually, in this setup, the source and the gate are tied together. And oh yeah, here's what the amplitude looks like. So let's go ahead and toggle the signal. I'm going to turn it off now. And back on. Off and on. We can change the frequency. So like for instance, I can do 500 kilohertz. And the density of the ones and zeros up here changes are 250 kilohertz, 125 kilohertz. So it seems to be behaving as expected. Now here is essentially my question. What I'm using now is an RF transistor, but in the demonstrations by Michael Osman and others, people have been using things like the 2N7000 transistor, and I'm confused about how that's working since it's not rated for 2.4 gigahertz operation. So if anyone knows and could give me some pointers on that, that would be great. But otherwise, I hope this was instructional. Cheers.